In section 7.3, we're going to be looking at some new properties called the sum and difference identities. Now the deal is we have special angles and we have quadrantal angles, and we could actually use those to find other angles. So we're going to use a combination of special and quadrantal angles to find new angles. And let's make a little list here so you remember the angles we've talked about. 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Those deal with our special triangles, and we have a quadrantal angle there. And then to get our other special triangles or special angles, we add 30 to 90 and we got 120. You might remember that when we were evaluating angles of special trig functions. 45 plus 90 is 135. 60 plus 90 is 150. 90 plus 90 is another quadrantal angle. So you can see what we're doing here, right? You could take 30 and add it to 180. 45, add it to 180. 60, add it to 180. 90, add it to 180. And we could just keep coming up with more special and quadrantal angles. So what if I asked you to find the sine of 15 degrees? Well, 15 degrees isn't one of the angles that we know how to work with, but we can do 45 minus 30 to get 15. That's what we're going to be working on today. We'd use a difference identity for that. What if we had 105 degrees? Well, we could use the sum identity with these two angles. So let me show you what those identities are. So the sum and difference identities are, I'm going to write it three formulas. So watch this. Let's say if we have the sine of A plus B. Like if you want to get 75 degrees, you would do 30 degrees plus 45. The formula for the sine of a sum would be the sine of the first times the cosine of the second plus the cosine of the first angle sine of the second. Now what if you were subtracting? If you wanted to get 15 degrees from 45 minus 30, you could subtract here and you could subtract here. That's how that works. So instead of writing two separate formulas, I'll just write it once and you could remember the sign changes. Now let's talk about the cosine. If you had the cosine of an angle plus another angle, the formula that we're going to use is the cosine of the first times the cosine of the second, but it's the opposite sign times, and then we have the sine of the first times the sine of the second. So you can see a difference between the sine formulas and the cosines. Sines use consistent formulas. Cosine, it looks like we're going to be using the opposite sign. And we have one more. Let's talk about tangent. Now the tangent of an angle plus another angle, the formula looks like this. Tangent of the first plus the tangent of the second divided by 1 minus the tangent of the first, tangent of the second. If we were going to be subtracting, we would use subtraction symbol here, subtraction symbol here, and an addition symbol there. So let's take a look at some examples now. Find the exact value of each expression. So let's see here. Let's start with this. The sine of negative 15 degrees. So you have to think of two angles. How could you add or subtract those angles to get negative 15? Well, we could do the sine of 30 degrees minus 45 degrees. That would give us negative 15. In this case, A would be 30 and B is 45. So that sign just tells you what formula you're using. The actual angle isn't negative 45. The angle's like just 45. So hopefully that clears things up. Let's draw 30 degrees for reference when we go to use our formulas. And we'll also draw 45 degrees. So our formula for the sine of an angle minus the sine of another angle is we use the sine of the first, cosine of the second, and then we're going to keep the same sign, and then the cosine of the first times the sine of the second. So now let's fill in what these are. It's really not a complicated thing, it's just some new formulas. Looking at our triangles, the sine of 30 degrees is 1/2. Cosine of 45 is 1 over root 2. But you know we're going to have to rationalize this, so just to save us a little bit of work, I'll rationalize it. And 1 over root 2 is root 2 over 2. Cosine of 30 is root 3 over 2. And the sine of 45 is also 1 over root 2. Rationalized is root 2 over root 2. This would just be root 2 over the square root of 4. So let's see what we get here. We'd have root 2 over 4 minus root 6 over 4. And our final answer would be root 2 minus root 6 all over 4. You can't simplify that anymore. There's no radicals in our denominator. That's the best answer. Now, if you were to type in sine of negative 15, and you were in degree mode, sine of negative 15 is an irrational number, negative 0.2588. That's never acceptable. We want the exact answer, and that's what we would get if we use radicals. Okay, let's try 3 more. Let's try one with radians. How about the cosine of pi over 12? Okay, well, if you don't remember what pi over 12 is, remember pi radians is 180 degrees. So you could just do 180 divided by 12, and that's 15 degrees. Or we could even do pi over 12 times what you want over what you don't want. Either way, you get 15 degrees. So really, this is just asking you what's the cosine of 15 degrees. So using our special triangles, we can get 15 degrees from picking whatever combination you want. We could use 45 and 30 again. If you want to be different, let's use 60 degrees minus 45. It doesn't matter which two angles you pick, as long as when you add or subtract them, you get 15. Now, the cosine formula says we take the cosine of the first, cosine of the second, opposite sign, and then the sine of the first, sine of the second. Well, let's draw these angles out so we could figure out what values we're going to be using. 60 degrees looks like this. So this would be 1, 2, and root 3. 45 degrees would look like this. 1, 1, and root 2. So let's answer this. Cosine of 60 would be 1/2. Cosine of 45 would be 1 over root 2. We've already talked about that rationalizes to root 2 over 2. Sine of 60 is root 3 over 2. Sine of 45 is 1 over root 2, which we rationalize, and we get root 2 over 4 plus root 6 over 4, giving us root 2 plus root 6 all over 4. Similar to what we got in the last example, but in this case we have a plus sign. Let's try a couple more. What about the tangent of 165 degrees? Now 165 is a big number. I'm thinking maybe we could use 45, but let's see what our angles look like, and we will pick two that either add up to be 165 or subtract to give us 165. All right, so if we have to get 165 right away, I'm seeing 30 degrees and 135. That would get the job done. We could also do 45 and 120. That would give us the same answer. So it doesn't matter which one we use. I'm kind of in the mood to use 30 and 135. So let's see how this pans out here. So 30 degrees plus 135. Now when we're doing the tangent, it's the tangent of the first plus, same sign goes on top, opposite signs on the bottom, the tangent of the second divided by 1, opposite sign, tangent of the first, tangent of the second. Okay, so we have to draw 30 degrees, so we know what to plug in here. We get 1, 2, and root 3. And we have to use 135. 135 is going to be over here with a 45-degree reference angle. Remember, anytime you go left or down, that's a negative side. So this would be negative 1, 1, and root 2. So let's plug in and see if we could figure this out. The tangent of 30 would be 1 over root 3. We're going to have to rationalize anyway, so I'll just rationalize here. So we could just put the answer in our work, root 3 over 3. Plus the tangent of 135. Well, tangent of 135, we're going to use this. Opposite over adjacent is negative 1 over 1 minus the tangent of 30 times the tangent of 135. What I'm going to do now is simplify root 3 over 3 minus 1 over 1 plus root 3 over 3. And in one of our very first sections of this semester, we saw rational expressions like this. Let's get rid of the fractions right off the bat by multiplying by 3 over 3. That would cancel out our denominators. And then maybe we could use a conjugate. We get root 3 minus 3 over 3 plus root 3. Multiplying by our conjugate would be 3 minus root 3. And let's see what this is. So I'm going to distribute at the top 3 root 3 minus the square root of 9 minus 9 plus 3 root 3. And in our denominator, we get 9 minus 3 root 3 plus 3 root 3 minus the square root of 9. So the square root of 9 is 3. So we have negative 3 minus 9 is negative 12 plus 6 root 3. Usually we put the radicals at the end. And then 9 minus 3 is 6. So we're almost done. We could actually divide everything on top by 6. We'd get -2 plus √3, which would be our answer. We'll do one more example. It's a little bit different here. What if I asked you, what's the sine of 40 times the cosine of 50 plus the cosine of 40 times the sine of 50? Well, that's a little bit different than the other problems we were looking at. Which formula does this look like? It's definitely not tangent, right? And remember, the formula for the sum and difference of cosine is cosine, cosine, and then whatever sine, and then sine and sine, right? So this looks like a sine formula. If this is A and this is B, the formula would be the sine of A, it's the same sign, plus B. And that formula would be sine of A, cosine of B, same sign, and then cosine of A times the sine of B. That's the formula it looks like, and it looks like A is 40 and B is 50. Well, okay, so we know what formula it is, right? This is just the sine of 90 degrees, which is a very, very easy quadrantal angle. 90 degrees is right here. 1 unit away would have the coordinates 0, 1. And remember, sine of that angle would be the y value, which is 1. That would be our final answer. All right, so thanks for your attention for the sum and difference identities. Stay tuned for our next topic.